Newton's law of motion describes the movement of matter, which directly relates to the surfer's ability to stay afloat. Newton's first law states that an object in motion, like waves, tend to stay in motion, while objects at rest, like a floating surfboard, tend to stay at rest. This is why a surfer has to paddle to catch a wave or be pulled by a jet ski to keep his motion. Newton's second law asks, how do we get objects into motion and how do we make them stop? A force needs to be applied. This force produces an acceleration that speeds the surfer up or slows him down. Therefore, the force of the wave and surfer is equal to the mass and acceleration. Because the surfer has a smaller mass compared to the greater mass of the wave, he will have a greater acceleration and move quickly down the slope and across the face of the wave. The force of gravity is dependent upon the mass of the object it is acting upon. Because the force is equal to the mass times gravity, gravity is 9.8 meters per second squared. Gravity is pulling you down the face of the wave, while buoyancy, an upward force that keeps an object afloat in liquid, pushes you up, thus creating a balance between you and the water, allowing you to stay afloat and continue on the wave. If the surfer wants to catch the wave, he must match the speed of the wave. In order to match this speed, the surfer must use the gravitational potential energy of the wave. By digging into the water to pull himself forward, the board will begin to fall down the face. The wave has enough force to allow the surfer to keep balance and use spring potential energy to push up off the board and stand up. As you take the massive drop, the gravitational potential energy you gain is converted into kinetic energy. The surfer is then traveling at the same speed as the wave. As this surfer continues down and through the wave, and as the time of his drop increases, his velocity does as well, creating a projectile path, connecting his horizontal vectors to his vertical vectors. This is because gravity is accelerating them down towards Earth at the same rate, so the longer the surfer progresses through the wave, the faster he goes. Friction is a force that resists a relative motion between two bodies in contact. Mu is used to calculate the force of friction by dividing force friction by the perpendicular force exerted by a surface on the object, the normal force. You divide the force of friction by the surfer's weight added to the weight on the surfboard to find the coefficient of friction. The force of the wave multiplied by how far the surfer travels, which is the distance, is the amount of work the wave did on the surfer. Once the wave is over and has hit the shore, the energy of the wave is neither created nor destroyed. The currents of a previous wave retract back into the ocean and build up the face of the next wave, making it larger. This wave breaks and follows the same pattern, conserving the energy of the wave.